Hey everybody, Daniel here from Basement Tech. Well, the topic for today, auto-zeroing a CNC machine. For those of you who have CNC machines, particularly of the hobby variety, you know that every time you change the cutter, you have to tell the machine where the tip of the cutter is by executing a zeroing sequence. I've been using paper or shims or all of that kind of thing, and you just kind of move Z down slowly until it pinches the paper and then hit the zero. Well, that's time consuming and probably not as accurate as it could be, so I wanted to implement auto zeroing. Lots of videos on this topic, but I just wanted to show you my version of an implementation that does that. So in the opening clip, you saw the end. Let's rewind and I'll show you all the gory details that got us there. All right, well, as always, these projects start with gathering parts out of the junk box. Looks like I did pretty well here. So I would rather have a little aluminum/metal box, but I think this box will do pretty well. I won't be taking advantage of the clear bottom, but it is a good size to fit all of the parts I think I'm going to use. So flexibility, I think, is key here, and therefore I intend to mount up this banana plug adapter, 5-way binding posts, so they unscrew and you can put wires or you can plug things in. That'll kind of go on one end, and then I'll use either these, which are very robust. The spring tension in these connectors is very good, and I think I can make that very robust through use of some shrink tubing. So that will be used to connect maybe these. So in a very robust connection to the cutting tool, the worst thing that could happen is this pops off midstream, the signal never gets sent back, and that expensive cutting tool gets jammed into the metal sensor plate. So at least to connect to the cutting tool itself, I'll use something very robust like this. Maybe get a smaller one for the really tiny cutting tools. And then of course connecting to the plate, I think I'll probably just thread and screw the wire on with a terminal, but I may opt to just drill a hole like some do and put a banana plug on each end of that. So again, going for robustness, I'll think about that design a little bit. And then finally, I was thinking, gosh, wouldn't it be nice to have a test button, at least for when I'm setting it up, and even for sort of periodic quality assurance sort of testing. So this is a fun switch in that it has a very large deadband. So I press it most of the way and it has not yet engaged, and then there's a tiny little click at the end and a robust micro switch that is actually the mechanism behind this switch. So that should prevent accidental pushes, but during the testing phase and afterwards, I think this will be a good switch, and I can label it on top test, and I think that'll be pretty good. Lastly, I'm debating whether to put an LED in. I have to investigate the circuitry a little bit and see if that'll work out. I was really trying to find a nice wire that's going to go from this box back down to the control box. I'll definitely use a strong strain relief like this, but what wire? It needs to be very flexible so that it's not tugging on this box when it's in use. I searched and searched, and I think in my junk box application, the best I'm going to do is just repurpose this old USB 1 or 2 cable. It's going to pain me greatly to cut those connectors off the end, but I think this cable is flexible and it's long, and I think in the end it will do a good job. I didn't mention running from this box actually up to this clip to the cutting tool. I'm going to use some of this meter probe wire, hyper flexible and very strong. I obviously don't need the voltage rating, but the flexibility is the key here with this silicone insulation. Okay, well, the physical build went really well. Here's the little box with all of the connectors mounted and all of the individual wiring. I'll go over the schematic on a piece of paper here in just a second, but in the upper left is that switch, which is wired as just a test switch across the red and black banana plugs. The LED, I decided to just make a power LED that indicates that the other end of the cord is plugged in, so you have some confidence before you press the button. And then the black connector will connect to the probe itself, the cutting tool, and the red one will connect to the plate. Well, here you go schematic-wise. Pretty straightforward, except for one small complication. You might remember, actually nobody probably does remember, it was quite a while ago, I had to implement this level shifting circuit with this MOSFET to get from the 12 volt inductive proximity sensors to the 5 volts, which the breakout board really wanted. Other than that, it is pretty straightforward. Over here you have the plate and the tool and the 2 banana plugs. The LED simply goes from the plus 12 input to ground, so it's on when the plug is plugged in. One really important fact is that 12 volts appears on the plate when it's not grounded, except that it's severely current limited by this 47K resistor. So even if you were to throw the plate onto a grounded surface, it wouldn't be too big of a deal. That would simply be milliamps, I believe, if I can do the calculation in my head. So this is the pull up, pulls us up to 12 volts. When the plate touches the tool, that gets pulled down to ground. That turns the transistor off and pops this up to 5 volts, which the breakout board sends out to Mach 3. So that's really it. Pretty straightforward and simple. Oh, by the way, the 100K here is just to drain the charge off of this MOSFET, and that's all part of the level shifting board, which is separate from the little box. This little dotted line here just indicates which parts are actually in the little box. Okay, well here it is all put together. Here's that interface box mounted on a substantial piece of scrap metal just to give it some heft so it doesn't move around. But these cables are very, very hyper flexible. Those are Tesla cables, and comes around to this piece of brass that's 0.274 inches thick, and a very substantial clamp that clamps right onto the cutter. I chose this relatively small electrode at the bottom just so that I can fit it into places where I might need to do V-carving and that kind of thing. So here goes, I'm going to give it a try. Okay, well, the user interface there says Z-axis 0, so it should be exactly 1 inch above the material. That's pretty awesome. Let's just take a quick look at the electrode itself and see if there's any indication of any marks, and I don't see it. So good. That's awesome. It works just as advertised, and this is going to really speed things up. You noticed I started pretty far away from the part. Well, that's just because I was being hyper cautious. I would probably move it to within about ½ an inch and then let it go. I'm also moving at only 2 inches per minute, which is really relatively slow, but I think that prevents, that lessens anyway, the overshoot. So, well, this is going to be just awesome. Well, there you have it, right back where we started. A couple final thoughts as I close the video. Number one, I literally didn't buy a single part for this project. So when I talk about going to Hamfest and buying parts, or somebody gives me a box of parts and I put it on the shelf for future projects, I recommend you do the same thing. Secondly, what should appear above is a link to the video that I've referenced where I got the Visual Basic code, and it's just a really good, well-discussed treatment of this topic. I recommend you watch that. As always, if you like these videos, please give it a thumbs up. If you really, really like it, please subscribe, and comments are always welcome. Thanks, bye.